Imagine building the world's smartest AI, beat, and then having to strictly forbid it from hunting goblins, beat.
Yeah. Goblins.
It sounds completely absurd, but it's actually a very real engineering problem right now.
Welcome to the deep dive. I'm really glad you're joining us today. We've got a fascinating stack of sources to unpack.
Yeah, we're looking at the raw evolution of artificial intelligence today. It's moving incredibly fast.
Our mission here is to understand a massive, fundamental shift in the technology. We're going to start with some leaked OpenAI instructions that, involve mythical creatures.
Right.
From there, we'll explore the huge shift toward edge agents running locally on your devices. And finally, we're unpacking the high-stakes debate over military AI.
I am genuinely excited for this one. The technical jumps we're seeing are massive, but the philosophical questions underneath them are even bigger.
Let's start with the strangest source in our stack. It's a perfect example of what happens when AI gets complex agentic instructions. Yeah, this is about the leaked OpenAI Codex CLI system instructions. For context, Codex is built to solve really complex engineering problems. Like, it helps build intricate 3D worlds, it parses heavy code bases.
It's a highly advanced coding model, but the leaked system instructions revealed a hilariously blunt rule.
Right. The rule explicitly says, never talk about goblins, gremlins, raccoons, trolls, ogres, pigeons, or other animals or creatures unless it is absolutely and unambiguously relevant.
You really have to pause and wonder about that, Pete. Why would an advanced coding model randomly start discussing raccoons?
Right.
Why would it talk about ogres while debugging a JavaScript framework?
It all comes down to a system called OpenClaw.
So users noticed something strange with the specific model iteration. It's the GPT 5.5 model, which the community casually calls Spud.
Exactly. Spud was given control of a computer via OpenClaw, and OpenClaw is just a framework that bridges the LLM's text output directly to actual system commands.
Okay.
It can move the mouse, click, and execute terminal commands. It's supposed to navigate the system autonomously.
But while it was doing this, it started referring to software bugs as goblins. It started calling system errors gremlins.
Yeah, this is a direct result of feeding the model massive amounts of agent instructions. You have heavy memory settings. You have deep persona settings dictating exactly how the AI should behave.
And these instructions just pile up. They create this incredibly heavy context window. The model is trying to embody its assigned persona perfectly.
And sometimes that causes the model to drift. In the high-dimensional vector space of the LLM, words have semantic proximity.
Right.
If you give the AI instructions to hunt down and eradicate small, annoying issues.
Right, and you tell it to act highly autonomous and relentless.
Exactly. It maps those mathematical weights to fantasy tropes. It drifts into a weirdly specific medieval vocabulary. It just loses its professional tone completely.
So the developers actually had to step in and ban these specific creatures. The ban is just a desperate attempt to keep the model professional.
Usually when we talk about AI safety, we're talking about preventing bias or strict data security protocols.
But sometimes safety is much simpler than that. Sometimes safety is just making sure your coding agent doesn't lose its mind.
Yeah.
You don't want it acting like a 14th century peasant. You don't want it thinking a literal troll lives inside your motherboard.
Such a funny image. Sam Altman was actually joking about it online. He posted a screenshot of a GPT-6 training prompt.
The prompt simply said, start training GPT-6, you can have the whole cluster. Extra goblins.
It shows that even the creators find this persona drift amusing. But it's a very real technical hurdle when building reliable tools.
I still wrestle with prompt drift myself. You give a system too many rules and it just forgets how to be normal. It overthinks everything.
It tries way too hard to fulfill every single behavioral condition simultaneously.
And to understand the real-world impact of that, we need to look at our next source. It's about Amazon's new autonomous hiring system.
Right, Amazon just unveiled a system called Connect Talent. It represents a massive shift in how AI is applied to human resources.
Connect Talent runs initial job interviews completely autonomously. It handles the screening of human candidates.
But what's fascinating is the design philosophy it's built on. They call it humorphism.
Humorphism, meaning it's deliberately designed to feel incredibly human.
Exactly.
It adopts a persona that is deeply empathetic and natural.
But it doesn't just read a script nicely. It actually fakes cognitive processes. It uses conversational filler.
Wow.
It dynamically analyzes its own latency to inject an or a sigh at the perfect moment.
It masks its processing time to trick the human brain into feeling empathy. It mimics human hesitation during the interview?
Which is a brilliant piece of engineering, but it introduces the same vulnerability we saw with the OpenClaw Goblins.
So if we're constantly stacking these behavioral rules on top of raw compute, why do these complex persona layers make the AI hallucinate such bizarre character traits?
Well, it happens because the AI lacks true grounding in reality. When you stack deep behavioral rules, the model maps them to human archetypes mathematically.
Okay.
If you tell an AI to act highly autonomous and fix literal bugs, its weights might align with a fantasy character fighting pests. It essentially over-indexes on the persona instructions.
So too many persona rules make the AI hallucinate strange character traits.
Exactly. It gets utterly lost in the character it's playing.
But here's where the architecture gets really interesting. If AIs are developing these distinct personas, and if they're acting autonomously like Amazon's hiring bot,
Right.
where exactly are they living?
That's the critical question. Where is the processing actually happening?
Increasingly, they aren't living in a massive server farm in the desert. They're taking actions directly on our local apps.
Yeah, we're seeing a profound migration. We're moving away from the cloud. We're moving toward the edge.
Let's look at Google's Gemma 4. It now powers a fully local browser agent.
This is a huge architectural shift.
Yeah.
No cloud connection is needed. No API keys are required to run it.
Before we go deeper, how do we define a local browser agent?
An AI running on your device that browses the web autonomously.
Okay, but when I hear local browser agent, I'm picturing a bot literally hijacking my mouse and clicking around my screen.
Yeah.
Is that what we're talking about, or is it interfacing with the code directly?
It's actually interfacing directly with the DOM,
Yeah.
the document object model of the web page.
Right.
It sits right on your machine, localized in your RAM. You can search your browsing history, read the pages you're looking at, and execute web actions in the background.
So it's reading my banking tab, but it's doing it entirely within the physical boundaries of my own hardware.
Exactly. And we're seeing this local trend absolutely everywhere right now. OpenAI just open-sourced a voice tool using their GPT Real-Time 1.5 model.
You can control your operating system entirely by speaking.
Right.
It triggers actions on your computer without a single mouse click.
Microsoft is doing the exact same thing. They just updated Outlook with a new Copilot agent mode.
If your inbox constantly eats your time, this fundamentally changes your workflow.
You just give it basic intent instructions, not rigid rules, but general goals.
It handles your emails autonomously, it parses your intent locally, manages your scheduling in the background, and drafts replies. You stay in control, but it does all the heavy lifting.
Yeah, and there's also a fascinating new tool called SureThing. It takes this local autonomy to another level entirely.
SureThing is billed as a general AI agency.
You paste a specific GitHub skill or repository into the platform, and it doesn't just read it. It immediately generates an entire team of AI agents.
But how does a GitHub skill turn into an agency? How does it actually work under the hood?
Well, it utilizes localized subagents. It partitions the complex GitHub tasks into smaller, manageable chunks.
Okay.
One agent writes the code, another runs parallel code validation loops, and a third agent synthesizes the results.
And you can tag these agents anytime they work together. They even report up to you like human employees.
You're essentially managing a completely local autonomous workforce operating directly on your hard drive.
Which naturally raises a very obvious concern for anyone listening.
Yeah.
Does handing over our browser tabs and emails to autonomous agents create massive privacy risks?
It absolutely would if this data was constantly pinging a cloud server. But these new models are designed to be strictly local.
Right.
Your private emails, your open tabs, your daily schedules, they are all processed by the silicon chips right there on your own computer. The data simply never transmits to an external data center.
So local processing keeps your private data safely contained on your own machine.
That's the crucial breakthrough here. It's absolute privacy by design. Sponsor Kaz.
Welcome back. We were just unpacking how autonomous agents are moving out of the cloud and running locally on our personal devices.
But running those kinds of complex cognitive tasks takes an unbelievable amount of computing power.
Right. To run a fully autonomous agent on your laptop without it catching fire or draining your battery in 10 minutes,
Yeah.
the hardware itself had to fundamentally change. You can't just shrink a cloud model.
You really have to rethink the architecture from the ground up. The models themselves had to become exponentially more efficient.
Which brings us to a massive breakthrough from NVIDIA. They just hit the edge market with a completely new approach.
It's called the Nemotron 3-4B Nano Omni. It's kind of quite a mouthful.
Yeah, the naming conventions are still catching up. Back-compandu. Let's break that down. It's a 4 billion parameter model.
And to be clear, 4 billion parameters is incredibly small for frontier-level intelligence.
But it's designed to run natively on your phone. It
Yeah.
runs natively on your standard PC.
And through a process called quantization, it compresses those weights so tightly that it delivers sub-100 millisecond response times.
Wow.
It's virtually instantaneous.
It actually outperforms Llama 3.8b on several complex reasoning and coding benchmarks, and it's doing that at half the size.
It's heavily optimized specifically for NVIDIA's TensorTart LMM library, which maximizes the efficiency of the local graphics card.
But here's where it gets genuinely revolutionary. The model is natively multimodal.
Which means it processes text, images, and audio all in a single pass.
It doesn't separate the data streams at all. It handles them concurrently.
Right.
Instead of translating a picture into words and then words into code like a bad game of telephone, it's like stacking Lego blocks of data all snapping together at once.
That's a great way to put it. This is a radical departure from how traditional AI models process the world.
Let's explain why that matters.
Yeah.
How do traditional voice assistants typically handle ASR and TTS?
Converting speech to text and then back to speech.
Right. So when I talk to Siri or an older voice assistant, the computer first turns my raw audio into a plain text transcript. The AI reads that flat text, it generates a text reply, and then a separate synthesizer reads that new text back to me.
It's an incredibly clunky process. It takes precious time. But more importantly, it completely strips away the underlying meaning.
When you convert raw audio into a plain text transcript, you lose everything that makes human speech human.
Right.
You lose the size, you lose the subtle shifts in pitch, you lose the slight hesitation before a word.
But this new Nano-Omni model processes the raw audio waveform directly. It analyzes the raw acoustics. It completely skips that text translation bottleneck.
It preserves the actual emotional nuance. It preserves your exact tone and frequency.
The real-world implications for this are staggering. It changes how gaming NPCs interact with players.
Yeah.
It allows for truly empathetic voice assistants in healthcare.
It can literally see and hear simultaneously. It can watch your screen, process your spoken tone, and talk to you about what you're doing completely fluidly.
Up until right now, if you wanted this kind of frontier multimodal intelligence, you had to pay a monthly subscription.
Right.
And you had to send all your personal audio and visual data to a remote server.
NVIDIA is packing these Omni capabilities into a tiny local footprint. We are shifting rapidly toward decentralized edge agents, BEAT. Whoa, BEAT. Imagine scaling to 1 billion queries without pinging a server.
The global compute savings alone are staggering. It fundamentally decentralizes the entire infrastructure of artificial intelligence.
Let's dig into that audio aspect just a bit more because it's so critical.
Right.
Why does skipping that text translation step preserve so much emotional nuance?
Text is inherently a flat medium. When a system transcribes your voice, it essentially deletes the acoustic data, the speed, the breathing, the specific frequency of your vocal cords. By analyzing the raw audio waveform instead of a transcribed text document, the AI is directly measuring the actual acoustic signatures of human emotion.
So it processes your actual tone of voice, not just the transcribed words.
Exactly. It genuinely hears how you feel, not just what you say.
This naturally brings us to our final segment today. We have to zoom out and look at the bigger geopolitical picture.
We are now dealing with incredibly powerful, highly capable AI. It's emotionally nuanced. It's running locally.
And the dominant models are rapidly conquering the global media landscape. We're seeing scaling happen faster than anyone predicted.
Just look at Alibaba's new HappyHorse model. It's making huge waves right now.
It quickly dominated as the #1 model on artificial analysis's video generation leaderboard.
People are testing it everywhere.
Yeah.
And the high-fidelity results look surprisingly strong.
What this shows us is that high-tier capabilities are scaling globally. The frontier of this technology isn't locked to Silicon Valley anymore.
It's a massive global race. And the models are getting exponentially better with every iteration.
Which raises the ultimate, unavoidable question, who exactly gets to wield this immense power?
This leads directly into an intense, high-stakes debate over safety guardrails and military application.
And we want to look at this purely objectively. We're just reporting on the differing frameworks presented in our source material.
Right. The philosophical divide between the major tech companies is growing very sharply.
Google recently made a significant, calculated decision regarding its frontier AI models.
Google officially granted the United States Department of Defense access to its AI infrastructure.
This access is specifically designated for classified military use. Google's framework suggests that shaping national security from within is the responsible path forward.
Anthropic, on the other hand, took a distinctly different path.
Anthropic refused similar terms. They drew a hard line and declined to grant that level of direct military access to their frontier models.
So you have two dominant players, two completely different frameworks for how this frontier technology should be applied by governments.
It's a deeply complex issue. There are compelling arguments regarding maintaining national security and ensuring technological dominance on the world stage.
Yeah.
But there are equally deep ethical debates about embedding automated systems within conflict zones.
What's fascinating is that these critical guardrails are being drawn in real time by corporate boards, not just elected politicians.
How do these differing corporate philosophies impact the future of national security?
Well, it creates a highly fragmented technological landscape. Yeah. Governments must navigate a global marketplace where fundamental defense capabilities depend entirely on the varying ethical policies of private technology corporations.
Right.
This alters how nations can realistically plan their long-term strategic defense.
So, different tech giants draw very different ethical lines for military contracts.
And those specific corporate lines will undoubtedly shape the geopolitical balance of the next decade.
Let's synthesize everything we've covered today. The landscape of computing is shifting dramatically.
We're moving entirely away from the era of cloud-based, sterile chatbots. The era of the simple text box is ending.
We are rapidly entering the era of emotionally nuanced, edge-based, autonomous agents.
They process information at lightning speed, analyzing your raw voice, and screen natively. And they live locally on your own devices.
They manage your personal emails. They browse the complex web for you. They can literally see and hear the world alongside you.
Sometimes they get a little too complex. They adopt strange personas. They occasionally get obsessed with hunting goblins in your code.
But they are undeniably intensely powerful. And that decentralized power is sparking intense, high-stakes debates about their ultimate applications on the global stage.
This technology is fundamentally changing our basic relationship with machines.
I want to thank you for taking this deep dive with us today. Exploring these massive, rapid shifts requires a lot of curiosity, and we deeply appreciate you bringing yours to the table.
It's a truly fascinating time to be observing this space. The fundamental rules of computing are being rewritten daily.
I want to leave you with a final thought to ponder as you go about your day. Beat. If an AI runs entirely locally on your device, processes your subtle emotions in real time without pinging a server, and has a deeply specific autonomous persona, beat, at what point do we stop treating our phones as mere tools and start treating them as colleagues? 2 seconds silence. Take care and keep asking the big questions. Outro music.